Okay, we've been multiplying binomials. And we would have, for example, this right here. What is this called when we are multiplying? These two things are called the what? It started with an F. It should be factors, okay? When you multiplied them together, you got an answer. What was that answer called? Well, it was a polynomial, but there's another P word. The product, okay? And so when we went through, we did the box, or we multiplied, we did this double distributive thing, and you would come up with x squared plus 5x plus 6, okay? That's when after we've gone through and done the box. And remember, we put the factors on the outside, x plus 2, x plus 3, okay? And that's where we came up with the x squared plus 3x plus 2x plus 6. And I got the 5 because I added these together, right? So that's what we should know how to do. The other type that we've done, say, for example, we had this type of problem. Okay? Again, these right here are called your factors. It's the same thing. Okay? But to find our product, what would we have to do to find our product? To find the product, we could do this a couple different ways. Okay? We could go through and multiply these two things in the parentheses, these two binomials, and then we would have to multiply everything by 2. Or, because on one of the tests, they said which ones were equivalent, meaning what's equal to, and they would have all these answer choices where they either did 2 times the x minus 1, and they would have like 2x minus 2 times 4x, x plus 4. What did these are equivalent. What did they do to get this answer right here in the blue? Didn't they multiply the 2 times the x and the 2 times the negative 1? Okay, and then on this one, to find your product, you would have to go through and do the box, putting your factors out here, finding your answer, and that would be your final product. So you would have to multiply all of this together. So let's see, and a lot of times I like to do it like this. Let's see, I'm going to have the 2 out here, and I'm going to multiply the x minus 1 times the x plus 4, and I would have gotten x squared plus 3x minus 4. Okay? So that was me. I would have multiplied this right here, and don't worry about, because we should already know how to do it. I'm not doing all the steps. But now to find my final product, you have to take 2 times x squared, 2 times 3x, 2 times negative 4, and your product would be 2x squared plus 6x minus 8. Okay, look, here's my point right here. Now what we're having to do is called factoring. Focus for a minute, guys. We're having to factor. And what that means is we're going to be given the product right here. And we need to go backwards and find the factors. Looking at these products right here, looking at this product, what do you notice about all my coefficients, all these numbers? They're even, which means what number divides into them all? A 2. Oh, wait. Look what's out front here. A 2. That 2 that goes into all of these right here, that 2 is called the GCF. What does GCF stand for? Greatest common factor. Okay, so what if I had the numbers 16 and 12? I want you to go and I want you to think about these numbers, and I want you to write down what is the greatest common factor out of these two numbers. Okay, to find your greatest common factor, first off, let's think about this. What numbers, like if I split this up, Give me two numbers that multiply together to give you 16. 4 times 4 does work. Can 4 split up? It's 2 times 2, right? And this 4 is 2 times 2. So 2 times 2 times 2 times 2, all of that equals 16, correct? Okay, let's think about 12. How does 12 split up? We can do 6 times 2. How does 2 split up? No, that's prime. That's down at the beginning. How does 6 split up? 2 times 3, right? Okay, so the numbers that multiply together to give me 12 are 2 times 2 times 3. Now, this is how you guys used to do it in elementary school. Now, to find the GCF, the greatest common factor, a 2 goes into both of them, so I'm going to put a 2 here. A 2 goes into both of them. Is there any other number in the blue and in the red that are the same that I haven't circled already? No, there's not. Okay, so what's 2 times 2? So my greatest common factor to go into 16 and 12 is 4. Okay, let's try this again. Let's see. Okay, right here, find the GCF of 24 and 12. Okay, now, with this one, if you broke it up into pieces, you could go through, just like I did on that first one. There's going to be a couple different ways that I'm going to show you. Now, let me give you a hint, guys. On the GCF, what I would do is this. I would look at the smallest number first, this 12. Does 12 go into 24? It does, right? That's your GCF. If your other number goes directly into it, that's your GCF. No, the GCF is not 24. The GCF is 24 does not go into 12. 12 goes into 24. Okay, so wait. Let's look at this one. What if I gave you 3 numbers? Okay, I'll go back through and do it. Hold on. Okay, wait. If you did break it up, look. If you did break it up, I'd have 12. One way I could do it is 12 and 2, 6 and 2, 2 and 3, right? So I have 2 times 2 times 2 times 3. Okay, you could do that, but when you did it all the way down to this, you should have gotten 3 2s and a 3. What do you mean this? I'm doing it right here now. Right here? But not when you write them all out. You have to split up the 6. And then this one would be 6 and 2, 2 and 3, which would give you 2 times 2 times 3. Your GCF, there's a 2 in each one of them, a 2, and a 3, which 2 times 2 times 3 equals 12. Okay? Hold on. Don't worry, guys. Let's go. Whoop. Go back. There we go. What if I had 3 of them? I want you to try and figure out right now what would be the GCF out of all 3 of them. Ready? Okay, now if you did it the way I've been doing it with the factor tree, okay? 6 splits up as 2 times 3. So you have 2 times 3 for 6. 4 splits up as 2 times 2. 18 splits up, let's see, 2 and 9, 3 and 3. So you have 2 times 3 times 3. To find the GCF, what number is in common in all of them? There's a 2, a 2, and a 2. Okay, so there's a 2 in common in all 3 of them. Is there another number that's in all of them? No, there's not. There's not any else. The GCF is 2. Now, let me give you another hint. If all of these, see how all of these are even? You know that at least a 2 goes into all of them. All right, now let's try, we're going to try this other way. All right, let's go with 36 and 72. Now watch what I'm going to do. I'm not going to do that factor tree. Stop what look what we're going to do. I'm going to go through like this. I'm going to make a T-chart. Okay? The numbers that multiply together. Here we go. 1 times what gives me 72? Okay? 2 times what gives me 72? So if you don't know, go in your calculator and put 72 divide by 2. 36. Wait a minute. What's the other number? 36 is the other number. Does 36 go into 72? Your GCF is 36. No. This is the number that divides all of it. You're looking for what's the largest number that multiplies to go in there. Okay, now watch this trick. Ready? Go in your calculator. This needs to be our ancient Chinese secret. Let's go in here. Hold on, I gotta find it and remember it. Oh, I found it. Hold on. Here we go. Press on your calculator, press math. Okay. Arrow over to number. Okay. Go down to where you see GCD. Right there. And click enter. Right there, it's number 9, GCD. And press enter. Now we're going to put 36. You're going to put, see that, I'm sorry, not parentheses, that, that's not a dot, it's a comma. Woo. And 72. And the other side of the parentheses. Comma. Make sure it's a comma. Now press enter. It gives you your GCF. Okay. Okay, next one to find the GCF. Let's go with 108 and 36. Find the GCF using the calculator for 108 and 36. Okay, you guys keep saying 36. I just chose a number, so let's see if I... Okay, so if I go here and I go math, arrow over to number, I'm going to go to 9, and I'm going to put in there 108, comma, 36, parenthesis. I guess I did choose 36. Okay, somehow I did that again. I don't know. But watch this. So now if I do the T-chart, here's the other way. Okay, and this is where a lot of them are going to start by showing you. I'm going to start with 108. Please focus here. Start with 1. 1 times what gives you 108? 108. 2 times what gives you 108? So go in your calculator right now and take and do 108 divided by 2. 54. So I'm going to write that down. 54. 3. Does 3 go into it? So if I take 108 divided by 3, does that work? 36. Now see, you would stop there because that's the other number we're looking for. So that means this number would be your GCF. Okay? All right, now let's try another one. Let's see if I can come up with something that maybe doesn't have 36 in it. Let's see. Try this. Find the GCF of 89 and 36. Okay, so what we'll do, go into the calculator. we're going to go and put in there, let's see what I have to press, math, arrow over to number, go to GCD, 89, comma, oh, well, I did the wrong one. Hold on, let's try again. Math, arrow over, 89, comma, 36, enter. The GCD, the GCF is 1. Now, the way they're getting, you know, you look at it and you're trying to figure out what goes into it. 89, if I made a T-chart, 1 times 89, okay? 2 goes in, does 2 go into 89? 89 divided by 2? No, that doesn't work. What about 3? Does it? I don't even know. You got to go through 89. Well, I mean, I do know, but divided by 3. Okay, it doesn't go in evenly. Okay? So what you would do is you would make a T-chart for both numbers, and you would look and see to find what the greatest common number it is. And you're going to find that in algebra class today as your teachers go over it. Now, we're not just going to deal with numbers. What if I needed to find variables and the GCF? So, for example, I'm going to have x squared and x to the 4th. What is my greatest common factor between these? Now, I want you to see something. First off, what does x squared mean?
It means squared.
It means x times x, right? X to the 4th means what? It means that there's 4 x's. Now, to find the greatest common factor of your variables, there are 2 x's in this one. There are 2 x's in this one. X squared is the greatest common factor. Here's what you do. You see how they both have x's? You take that x and put it down there, and then it's what the smallest exponent. Okay, the smallest exponent. So let's see. Let me try a different one here. Let's do x to the 4th, y to the 3rd, x, y to the 6th. Okay. We're gonna find the greatest common factor. First off, is there an x in both of them? There is an x in both of them. Okay? So I know that one of my greatest common factors is going to be an x. What's the smallest exponent? I heard it. A 1. There's a 1 right here. So this is x to the 1st power, so I'm just going to leave it as x. Is there a y in both of them?
Yes.
Yes? What's the smallest exponent? A 3. So that's your greatest common factor. Okay, so let's try another one. Let's try another one. I've got x to the 3rd, y to the 4th, z. That's a z. Don't make fun of me. No. Let's see. All right, here we go. Let's find the greatest common factor. Finding the greatest common factor, let's look through here. This one has an x. Does the other one have an x? This right here, does this have an x? No. So x cannot be one of the GCFs. There's a y here. Is there a y in the other one? Yes, there is. So I know there's a y. What is the smallest exponent out of the y's? A 4. So it's y to the 4th power. The next letter that's in common in both of them is a z. What is the smallest exponent on the z? A 1. So your greatest common factor is y to the 4th z. Let's try and do one here on your own. Okay? Find the GCF of this. So now what you're doing, I choked myself here with the cord. All right, what you're doing, first off, you're looking to see there's a K in both of them, so the K goes here. What is the smallest exponent? Squared. M's are in both of them. Smallest exponent? Squared. Is there an N in both of them? There is not an N, so you can't put it down there. This is the greatest common factor. Now, we're going to have this. Let's see. Oh, I'll just go back to K's here. Okay, what do you notice that I did now? What did I do now with what I wrote in the problem? I added a what in the middle of it? A plus sign. We are going to factor out the GCF. And what we're going to do, okay, we're going to put the GCF right here, GCF, and then in the first term, we're going to put what's left of the K squared m to the 6th n, and this one we're going to put what's left from the K m to the 8th and the t. Okay, first off, out of these, to find the GCF, is there a K in both of them? Yes. What's the largest exponent? Is it squared? Isn't that just a 1 right there? The largest exponent is just K to the first power. Okay? Now, M, is M in both of them? Yes. What's the smallest exponent? Did I say K, what was the largest exponent? I apologize. Okay, I'm sorry. I should have said what's the smallest exponent. Should have been to the first power. Now, M, what is the smallest exponent? 6. Is there N in both of these? Okay, and there's a T over here, but there's not a T in both of them. So my GCF, I've pulled out what's in common in both of them. Now, right here, let's write what's left. I took out 1 K. How many K's are left? Well, this means K and K. I already took one of them out. So I'm going to write the other K in here. It says m to the 6th. How many m's are up here? 6, right? So I've got all of those right there. Now, n, I'm just going to put the n down here because I didn't pull it out. Look what's left here. Now, the K, I have a K. I have 8 m's up here. How many do I have out here? So how many do I have left? 2. So I have m to the 2nd power. And is there a t out here? No, so I put the t here. We just factored it out. Now, see, what we've done before is we would have taken this. If you take the GCF times this, the GCF times the second term, we would come up with this answer right here. Let's try a different one. Let's see here. Okay, let's start with this one. We're going to factor out the GCF. So the GCF is going to go here, and then what's left of the first term goes here. And right here is going to be what's left of the second one. Okay, so right now, first find the GCF. Okay, a lot of people get confused on this big coefficient right here, this 2. But don't worry about that right now. because there's not another number out here in the front. So let's look at what is in common. There is an m in both of my terms. So I'm going to put the m out here. And you're going to use the smallest exponent. So there is a 2 and a 6. So I'm going to put m to the second power. N. There is an n in both of these. What is the smallest exponent? A 1. So this is my GCF. Now, right here, we're going to write what is left. Okay? First off, I pulled out an m squared. That's all there is, m squared. So I've already got it. I don't worry about it. I don't write it here. Now, this says n to the fourth. I have one n here. How many n's are left? If I take one of them out of here, it's n to the third power. Now, the m's went away because when I go back to take this times this, that's when it puts it back together. Okay, hopefully in the next step I'll be able to help make some more sense. Right here, the 2 needs to come back here. There are 6 m's here. How many did I pull out? 2 of them. How many are left? 4. M to the fourth. I need an n in this one. I pulled an n out so I don't have to put it back in there. This is my answer. All right, let me do this. Ready? We're going to go over here and I'm going to do something. Oh, not that. Let's try this. Do. All right, ready? Look at this here. I want us, this right here is my product. I want us to factor out the GCF and write what is left. So right here, we're going to put the GCF, and you're going to write what is left. So let's look at this one. There's only an x here. There's no x's here. What number is the greatest common factor out of 2 and 4? 4 goes into 2? 2 goes into 4, right? So I'm going to pull a 2 out. If I pull the 2 outside here, what's left out of this first term? Yeah, because 2 times what? 2 times what gives you 2x? 2 times x. If I pull out this 4, I'm not a 4, I'm sorry, on this 4, if I pull out a 2, 2 times what gives me 4? 2. That is factored completely. Because what we did before was we did 2 times x, got 2x. 2 times 2 gave me 4. That's how you check it. You can go back because the whole idea is we're trying to go backwards from what we were doing. This right here is what we were doing. We were multiplying these together and doing the distributive property and getting the product. Now we're going from the product back to from the product to the factors. Let me show you another one. Ready? Okay, here we go. Let's factor. Find the GCF and write what is left. Okay, now, here's one way I can do this. I'm going to match it up with the box. I have 3x plus 12. And out here, this is going to be my GCF. Okay, what is my greatest common factor in these two terms? Why is the x not the GCF? Is there an x with this 12? No. So the GCF is 3. So I'm going to pull this out. Now watch. 3 times what gives me 3x? 3 times what gives me 3x? X, right? Oh, you know what? I did this backwards. Haha, crazy me. Okay, I'm supposed to put inside here. Sorry, the product goes inside the box. That's why it's backward. All right, 3 times what gives me 3x? This is the 3. That, man, you guys are confusing me. It's the x. So the x goes here. 3 times what gives me 12? Plus 4. Does this look familiar from what we did in the last one? The last unit? 3 times x gives me 3x. 3 times 4 gives me 12. That's what we're doing here. You may not always use the x in the parentheses. It just depends. Okay? Okay, the next one. The next one, let's try this. There we go. GCF. Right in there what's left. You can also do the box. And by doing the box, you're going to put the 6x minus 15 inside of it. And then the GCF goes out here. Okay, so now I'm going to pause for a minute and see, and you see how you can do it. For your GCF, your greatest common factor, if you don't know what the biggest number is that goes into 6 and 15, right here, I go in here, and I'm going to press Math, arrow over to Number, go to GCD, put in there 6, 15. You should find that it's 3. 3 is your largest number. So now 3 is going to come outside here in the GCF. Now look. 3 times what gives you 6x? 2x. Don't forget the x. 3 times what gives you negative 15? Negative 5. And I don't know why I put the plus in there. This should be 2x minus 5. Because to get the answer, you take, or to check it, 3 times 2x is 6x. 3 times negative 5 is negative 15. They're the same.